All right, so things to remember from last week when we talked about this stuff. First off, there are 5 different kinds of reactions that we went over. Synthesis, okay? Simple decomposition, or we usually just say decomposition, okay? A combustion reaction, single replacement reaction, double replacement reaction, okay? In a synthesis reaction, 2 elements combine to form a compound. A decomposition reaction is the exact opposite. A compound breaks down into 2 elements, okay? Combustion reaction, a hydrocarbon reacts with oxygen, okay, to produce carbon dioxide and water. In a single replacement reaction, an ionic compound reacts with an element, all right, to produce another element and another ionic compound. And in a double replacement reaction, 2 ionic compounds react with each other. All right, what are we looking at for number 1? What kind of reaction is that? It is a simple decomposition reaction because we have a compound here, and it is breaking down into its 2 elements, nitrogen and oxygen. All right, so we would say decomp for that one. All right, we're supposed to write it in words, so this would be trinitrogen dioxide, okay, gives nitrogen and oxygen. Okay, remember that we do not put prefixes in front of elements. All right, those are elements. They do not get prefixes, not dinitrogen and dioxygen. Okay, they're just oxygen and nitrogen. All right, now we got a balance. Always good to start with the thing present in the largest number. All right, and in this reaction, that's nitrogen. All right, there are 3 over here, and there are 2 over here. What's the lowest common multiple of 3 and 2? 6. So I'm going to try and make 6 nitrogens on both sides. All right, so I'm going to put a 3 here, or sorry, a 2 here, and a 3 here. So that gives me 6 and 6. It also gives me 2 times 2 is 4 oxygens. So over here, I need 4 oxygens. Everybody follow me there on the balancing? Okay, balancing's relatively straightforward. It's basically finding common multiples of things. Okay, and again, the general rule is that you start with whatever is present in the highest number, except on combustion reactions. They have some special rules, okay, but we'll go over those in a minute. Okay, in number 2, I have an element reacting with an ionic compound, forming a new element and a different ionic compound. What kind of reaction is that? Peter? Single replacements. All right, so SR, single replacement reaction. Okay, this is calcium, okay, plus iron 3 chloride. How could I tell that? How could I tell it was iron 3? Right, because chlorine has a charge of -1. That gives me 3 negatives. I had 1 iron. Okay, all right, that's going to give me iron and calcium chloride. Okay, now I got a balance. What should I start with on that reaction? Ellie, what should I start with? With the chlorine, right? Chlorine's present in the largest number. There's 3 on this side, 2 on this side. So just like we did in this reaction above, we need to find the lowest common multiple, which is 6. All right, so if I put a 2 here, that'll give me 6 chlorines on that side. And if I put a 3 here, it'll do the same thing. All right, now, when I put this 2 here, it gave me how many iron? 2. How many do I have over here? Just 1. All right, so I need to put a 2 here. All right, why can I not put a 2 here? What does that little 2 mean iron has done? Peter? Right, that it's a molecule of iron, that they've bonded to each other. Metals don't do that. Okay? All right, so I can't say that. Okay, I need to have 2 atoms of iron. All right, so now my iron is balanced, my chlorine is balanced, but I have 3 calciums over here and only 1 over here. So what needs to go in front of calcium? A 3. All right, is that making some sense? All right, so you just kind of, you put in numbers, and then whatever that number unbalanced, balance it. And then whatever unbalanced because of that number, balance it. So you're going to go back and forth from products to reactants until everything is balanced. All right, okay, I'll give you a few more minutes to try the rest, and then we'll go through them. Okay, let's have a look at number 3 here. So in number 3, I have carbon and hydrogen together, which we call a hydrocarbon, okay, reacting with oxygen to produce carbon dioxide and water. What kind of reaction is that? Combustion. All right. Thing to know about combustion reactions is that they have a couple of special rules for balancing. Two, in fact. Okay. The first rule is that you always balance in alphabetical order: carbon, hydrogen, then oxygen. Okay. The second rule is what we call the rule of two. That's why it's the second rule. Okay. If there are an even number of carbons, we start with a 2. All right. If we don't, we'll end up needing a 0.5 beside the oxygen molecule on the reactant side. Can you have half a molecule? No. Okay. Well, I suppose you could. It would be one atom, but we don't do that. All right. So we can't have a decimal on there, so we start with the rule of 2. If it's an even number of carbons, put a 2 in front and start balancing. All right. So balance in alphabetical order. 2 times 6 is how many? 12. All right. So I put a 12 here. All right. 2 times 14 is 28. All right. So 14 times 2 is 28. Now we've got our carbons and hydrogens balanced. Now we need to balance the oxygens. Over here, we don't have any numbers, but over here we do. 12 times 2 is 24. Plus 14 more is 38. Everyone follow me? All right. What times 2 gives you 38? 19. Okay? Carbon, hydrogen, oxygen, then the rule of 2. Okay? All right, and then if we were going to be naming this, okay, this is actually called hexane. Not that I would expect you to know that. Okay, there's rules for naming organic compounds, right? But if you had a number of hydrogens that was beyond the prefixes I gave you, so beyond 10, you could simply write fuel. I would be fine with that. Okay, reacts with oxygen. Okay, to produce carbon dioxide and water. You can write water for H2O. That's what it is. Okay, so just write water. Okay, how many people are done number 4? How many people are stuck on number 4? Okay, I'll give you a couple more minutes to do number 4 and 5. Okay, let's have a look at the last 2 here, guys. So for number 4, I've got an element reacting with another element to form a compound. So Larissa, what kind of reaction is that? That is a synthesis reaction. All right, now to name it, or to write it in words, chlorine, okay, plus lithium gives us lithium chloride. All right, and then to balance, if there's 2 chlorine over here, now there are 2 over there, but that gives me 2 lithium, so I need a 2 over here, and now it's balanced. Okay, is everyone sort of seeing how the balancing works? Right, because it's kind of the one thing we only kind of briefly touched on the other day. All right, and then our last one here, we've got an ionic compound reacting with another ionic compound to produce 2 different ionic compounds. So, Mitchell, what am I looking at there? Double replacement reaction. Okay, so now I need to write it in words. So we've got magnesium fluoride, okay, plus cobalt 3 nitrate, okay, gives us magnesium nitrate, okay, and cobalt 3 fluoride. Here's some good news for you. If you figure out what charge a multivalent metal has on the reactant side, it's always the same on the other side. All right, it would be impossible to balance the reaction if that were not true. All right, so once you figure out what the charge on a multivalent metal is, okay, it is the same on the product side as it is on the reactant side. All right. Now, to balance, what should I start with? Yeah, I'm going to start with nitrate. I mean, I could start with fluorine. It's also present in a large number, but it doesn't really matter. Okay, so there's 3 nitrate over here, and there's only 2 over there. Lowest common multiple of 2 and 3 is 6. Does everyone follow me? This 3 here means there are 3 nitrates, right? Okay, so I'm going to need a 3 over here and a 2 on this side. When I do that, that gives me 2 cobalt. So if I go over here and put a 2 there, that gives me my 2 cobalt, and it gives me how many fluorine? 6. So now I got to go back over here and put a 3 here to give me my 6 fluorines. And what does that do to my magnesium? It balances it. Always a good sign. Okay? When you are down to your last one, you should find that if you've done it right, the last number you put in balances the thing you haven't done yet. Okay? That's why we always leave oxygen for last, right? Because it's the thing that fouls everything up if you do it first. All right, is that making some sense? Well, it's balanced here because 2 times 3 is 6, right? So there's this 3 tells me there's 3 nitrates. 2 times 3 is 6, and over here 3 times 2 is 6, right? Okay, any other questions on that one? All right, so what we're going to do today and probably tomorrow, we're going to spend some time working on this stuff, okay? Because we got to be able to do balancing and writing out in words and all of that stuff before we can even think about doing our reactions lab. In fact, we need to be able to predict what the products are going to be before we can do our lab. So we got a little bit of work to do on reactions. This, guys, constitutes the bulk of the marks on the unit exam. Okay, on a unit exam, I will give you questions exactly like this. And I will say, tell me the reaction type, write it in words, balance it. Or I'll give it to you in words, ask you to write it in formula form, identify the type, and balance. And then there'll also be somewhere I'll only give you the reactants, and I'll say, predict the products, and balance. All right, so that's kind of where we're headed. But on the unit exam, this probably 30 to 40% of the test is reactions, right? Because this makes you do everything else. It makes you do naming, okay? Makes you write formulas, right? All that kind of stuff. So it uses all the skills that we've put together so far. When you are doing that that worksheet there, guys, okay, you can find the key for that so you can check as you go, right, on my website where you can usually find things, okay? Science 10 notes and assignments, chemistry. Okay, and I think it's called Keys to All Reaction Worksheets. Yep. Okay, Keys to All Reaction Worksheets. Okay, if you go there, you'll be able to check your work. I would say do 2 at the most, and then check. Okay, do 2, check. Do 2, check. All right, that way you don't get into a bad habit of something that might not be right. Okay, so if there's any there that give you trouble, guys, okay, we'll go through them together. Just ask. Okay, I've got it up here on the screen so we can go through them. Okay, listen up here, guys. One I want to look at here. Quite a few people are coming and asking about this one, and it's good that they are, because this number here, the 2 that I have on the oxygen in number 8, can be there, okay, but there's actually a better way to do it than actually having that 2 there. Now, here's the problem with a question like number 8, and actually number 9 on the next page with carbon monoxide and oxygen has a similar issue. On this side on the reactant side of this reaction, there is an even number of oxygens. On this side, there is an odd number. Everyone follow me there? Okay, I've got 4 on this side. Well, let's say that 2's not there. There's 4 on this side and there's 3 over here. Right? That's no good for me. All right? The best way to make an odd number an even number is to do what with it? Double it. Okay? Any odd number doubled is an even number. All right? I know you're doing that in your head right now. Okay? 1 doubled is 2. 3 doubled is 6. 5 doubled is 10. Right? It always works. All right. So what we need to do is let's put a 2 here. Let's double the number of oxygens over there. All right. Now I have 6 oxygens on the product side, and I have 2 sulfur. So I'm going to go back here, and I'm going to put a 2 in front of the sulfur. Everybody follow me so far? All right. Now, I have 6 oxygen over there. I've got 2 sulfur over here. And 2 times 2 is 4 oxygens. Plus 2 more is 6. Okay? The other way that people have done that one is to put a 4 here, okay, a 2 here, and a 4 here. Okay? Which, that's fine, but can you reduce 4, 2, 4 to 2, 1, 2? Yeah. Okay, and when you're balancing, you always put your balancing numbers in the lowest terms, right? And I actually forgot to do that when I made the key, which is why there was a 2 in front of that oxygen, okay? Because I forgot to reduce it down. All right, so if you got 424, you still figured out how to balance it, and that's good, because it's tricky, okay? Just understand that if you can reduce all your balancing numbers, you should, okay? Any other ones giving us trouble you want to go over? Don't be afraid to ask, guys. 11? All right, number 11, similar issue, right? Okay, we got an even number of oxygens on one side and an odd number of oxygens on the other. All right, so what I would say is, since we're not supposed to start with oxygen, right, because that always gives us trouble, I'm going to double the nitrogens. Because by doubling the nitrogens, I will have to put a 2 over here, which will get rid of my odd number of oxygens. Agreed? Okay, so now I've got 2 nitrogens over here, 2 nitrogens over here. How many oxygens on the reactant side? 4. Okay, and 2 here plus 2 more is 4. Balanced now? All right, so anytime you run into that odd-even problem, okay, double the thing that's odd, right? And then it'll probably work out from there. Right, that's your best bet. Any others? Okay. Don't be afraid to ask, guys. Chances are, if you're struggling with it, there are probably 5 to 10 other people who also are. Okay, you won't be alone. Okay, I'll give you a few more minutes there. Okay, so guys, when you get down to the second set here, and I understand if you're not there, that's fine. Okay, but if you are here, okay, what you need to understand is when we're working on these, if you don't swap and drop your compounds correctly, you won't get the equation to balance. All right, so if you can't get the equation to balance, you should always go back and check that your compounds were swapped and dropped correctly. So if we're looking at number 1 here, all right, it says magnesium and chlorine. Okay, now, on your periodic table, did we highlight chlorine? Okay, and we said that chlorine always comes as a pair when it's by itself. All right, so we've got Mg plus Cl2 gives us magnesium chloride. All right, so Mg and Cl, this is a -1, this is a +2. Okay, so when I drop and swap, I get MgCl2. And you can see that if I remember to swap and drop, my equation is already what? It's already balanced. Yeah. Okay, does that sort of make sense to everybody? Right, but when we're writing reactions in formula form, we have to be extra mindful of those special elements that comes as pairs or sets of 4 or sets of 8, okay, and mindful of our drop and swap on the product side. Right, that's what makes doing reactions that way tricky. Okay, is having to remember now all of those rules when we're in a reaction. Okay, any other ones you guys want to go over? Are you sure? Right? 13? I don't have a 13. 12? Okay. This one here? Oh, 13 on the other side, on the other one. That says 12 on mine? Okay, all right, so this one. KF and BAB, okay. All right, so we've got potassium fluoride reacting with barium bromide to produce barium fluoride, and this should be a capital B. I don't know why it's small. Okay, KBr. So what kind of reaction is that, first off? 2 ionic compounds. What? I don't have it? Yes, I do. It's just down where you can't see it, because I covered it up, trying to hide it. All right. Let's try that again. 13. Hydrogen, so this is supposed to be H2S. Yeah, it's hard to read. H2S plus O2 gives H2O plus S8. Okay? Sulfur's that special one that comes as an 8. All right. So if I'm going to balance everything, okay, sorry, what kind of reaction is it first off? I've got an ionic compound reacting with a non-metal, okay, an element to produce another compound and an element. What kind of reaction is that? It's a single replacement reaction, okay? And in this case, water behaves like an ionic compound, and that happens once in a while. All right, now, I'm supposed to start balancing with the thing present in the largest number, which means start with sulfur. There's 8 of them on this side. So if I go back over here, there's only 1 in hydrogen sulfide. So what needs to go in front of here? An 8. All right, Now, when I put that 8 there, that gives me 16 hydrogens. So I need to put an 8 here as well, because 8 times 2 will give me 16. And when I do that, it gives me how many oxygen? 8. So I go back over here, and I put a 4 there to give me 8 oxygen, and then a 1 there in front of the sulfur. Okay? Does that one make sense? If it was an exam where it was fill in the blank, yes. Because if you don't, I don't know whether you knew it was a 1 or you didn't finish. Does that sort of make sense? If it's fill in the blank, write ones, put something in every box. Okay? What number should never appear in a box? 0. Okay? Because if you put a 0 in front of something, 0 times anything is what? 0, and that means you don't have any of that. Okay? And that's not right. All right? So there should never be a 0 in any of the blanks when you fill these in. Yes. Any other ones you guys want to go over? Jane? Number 4? Okay. All right, so I've got phosphorus and oxygen produces phosphorus pentaoxide. This one is tricky because both phosphorus and oxygen are special elements. Phosphorus, when it's an element, comes as a 4. Oxygen, when it's an element, comes as a 2. All right, and then it makes phosphorus pentaoxide. That's PO5. Now, according to my rules, I should balance oxygen first because it's present in the largest number, except that I never balance oxygen first. So what should I start with instead? Phosphorus. All right. I've got 4 phosphorus over here, but only 1 on this side. So what should I write here? 4. All right. 4 times 5 is how many? 20. What times 2 will give me 20? 10. Done. All right. Again, if you try and balance the oxygen first, you're just going to be in a world of hurt. You're just going to keep changing numbers, changing numbers, changing numbers, and it's just never going to work. Okay? So always balance something other than oxygen first. Okay? Any other ones? Okay, keep going there, guys. Okay. Some people have gotten to the second page here, guys, second sheet. Now, on here, there is something that throws people off sometimes, and that is on examples like F, okay, and G, where on this side, on the reactant side of F, we have H2O, but then on this side we've got OH and H, and it gets difficult to track where that stuff came from. Where do you suppose the OH came from? Is there another way to write water? HOH. So anytime you see that happen, okay, where you've got H2O on one side and OH on the other, write H2O as HOH. And then it becomes a lot easier to track where everything goes. Okay? The hydrogen from here goes here. And the OH goes here. Now you got to do a little balancing to make that work, okay? But that makes it a little easier to track, okay? And it's the same thing for the one below. You got HCl and CaOH2, and then suddenly you got H2O. Well, if you write that as HOH, it becomes a lot easier to track where the hydrogen came from and where the OH came from. Everybody follow? So that's a little tip there, okay? That'll hopefully help you out.